All right, in this video I'm going to be working the problems from the homework in Unit 13. It's the review of what we already know about differential equations. I think, I don't know, maybe in the future this will be labeled 13.0, but we're going to start considering the equation dy dx is 2y minus x, and we're going to sketch slope field. We can do that. All right, so I think what I'm going to do is I'm going to just actually go and do all 9 of the points. So y has 3 points where it's 0, 3 points where it's 1, and 3 points where it's 2. And who knows, maybe by the time I get there I'll be able to just figure out what's going on here. And so x goes negative 1, 0, 1, 1, and then I'll do the same with y equals 2. Okay, so 2y minus x is going to be 1, 2y minus x, 2y minus x. All right, so at negative 1, 0, the slope is 1. 0, 0, the slope is flat. At 1, 0, it's negative. At negative 1, 1, we have a slope of 3, very steep. At 0, 1, we have a slope of 2. And at 1, 1, we have a slope of 1. All right, then maybe I'll just go over here. Yeah, you can see that. I'll do x, y, and dy dx. So I'll have negative 1, 0, 1. Y is 2 up there on the ones I don't have. So it'll be 2y minus x is 5. That's just, that might as well be vertical. 2y minus x, 2y minus x. All right. So this one's got a lot of steep slopes, but as long as it's getting less steep as we go from here to there, and we have that 0 slope, getting less steep as we go over here and having positive, negative, and we're going to get credit for this problem. All right, find the second derivative of y with respect to x both times in terms of x and y only. Well,
negative 3 minus the 4.75.
We're going to find that by taking the derivative with respect to x of dy dx, right? And so that'll be of 2y minus x, which is going to be 2 dy dx minus 1. Wants it in terms of x and y only, so I'm going to say that this is equal to, hold on a second, what am I looking for here? Oh, 2 times 2y minus x, then again minus 1. And then it says determine the concavity of all solution curves for the given differential equation in quadrant 4. So what I'm going to say is one thing I know about quadrant 4, and you can't see because I forgot to scroll it down, my bad. In quadrant 4, x is greater than 0 and y is less than 0. Okay, that means the second derivative y with respect to x both times is going to be equal to 2 times a negative number, minus a positive number, minus 1 is certainly less than 0. That's what I'm trying to show you. And so that would be concave down. Right? All right, and I think I'm going to, hold on a second, take this away, fold it a little bit, and I'll just copy the differential equation. Yeah, dy dx is 2y minus x. All right. 2y minus x, f of 4 is equal to 2. So dy dx at the point 4, 2 is equal to 2 times 2 minus 4, which is 0. Okay, if we have a 0 slope, that means we potentially have a maximum or a minimum. We would need to look at it. Well, in this case, the second derivative is 2 times dy dx minus 1. I like this form better because I know what dy dx is at 0. So this is at the point 4, 2, that's going to be equal to -1, right? Because 2 times 0 minus 1. So since the derivative is 0 and the second derivative is negative, I am flat while concave down. That is a relative maximum. Okay, then write an equation for the line tangent to the graph of g at the point where, oh, okay. Well, I've got a point. That's 3, -2. My slope is 2y minus x. So my equation is y minus -2 is -7 times x minus 3.
I did like double. So I tried to do it in my head and I was thinking,
Does it sit above or below the graph of y equals g of x? Okay, well that's going to have to do with the concavity again, right? Because if it's concave up, it's going to be above the tangent line. And if it's concave down, it's below the tangent line. So what I'm going to do is I'm going to say, oh, wait a second, look, I already answered this question. In the fourth quadrant where x is positive and y is negative, I have already concluded that it will be concave down. Okay, so
16 pages of handwritten notes.
3, -2 is in quadrant 4.
It's 16 pages.
yeah, I think so. I got no idea.
Solutions
Like, if I can do it,
in quadrant 4 are concave down. Therefore, if it's concave down, the tangent sits above the curve.
did you not handwrite your other?
All right, that's number 1. Number 2, slope field for some old-fashioned differential equation. And they're going to give you the second derivative. Okay, that's polite because that looks pretty rough. Glad we didn't have to do that by hand. Sketch the graph of y equals f of x, the particular solution to the given differential equation with f of 1 is equal to 2. Okay, so this is 1, 2 is probably around here. Or this is where we just want to follow the lay of the land. So it's going to go down, and it's probably going to be something like this. And that's all you got to show. All right. On the slope field, write an equation for the line tangent to the graph of f at x equals 1. Well, I've got a point. F of 1 equals 2. The slope is going to be x times y to the 3. Well, x times y to the 3 is going to be 8.
You do one.
They have the other things.
And so the equation is going to be y minus 2 is equal to 8 times x minus 1.
Yeah, you're not going to do this.
Okay, so tangent line to approximate. So f of 1.1 is going to be approximately equal to y when I plug in 1.1 for x. Whoops. Get rid of that slope field, I think. And f of 1.1. Hold on just a second. F of 1.1 is going to be approximately equal to 2 plus 8 times 1.1 minus 1, so that's going to be 2.8. Given that f is positive, is the approximation greater than or less than f of 1.1? Well, that's interesting. I've got the formula for the second derivative. That's going to be what I'm going to need to consult with to determine if it's an overestimate or an underestimate. The second derivative of y with respect to x both times is equal to y to the third, which I know is positive because they said f of x is greater than 0, times 1 plus 3 times x squared times y squared. Okay, this has to be a positive number also, because if you take x and you square it, you take y and you square it, those are both positive numbers. You triple it, that's going to be even more positive, and you add 1, it's definitely a positive number. Okay, so this is going to be greater than 0. So since it's concave up, maybe we've got this type of a tangent line scenario, and that isn't, the approximation is less than the actual value of f of 1.1, right?
Oh, video available.
The SME.
55 minutes. You watch 55 minutes of a considered flag debate.
It's just entertaining.
The approximation is is less than. It's an underestimate.
I won on numbers.
All right, so find the particular solution y equals f of x with the initial condition f of 1 equals 2. All right, so that's where we start with dy dx, and that's x times y to the third. So then I'm going to scroll this down a little bit so you can see my work. And I'm going to, let's see, divide both sides by y to the 3. And x dx, anti-differentiate. All right, and then I'm going to kind of clear this out. Multiply by -2, so that's negative x squared plus c. And I think y will be equal to negative x squared plus c. If I want to get rid of the negative 2 power, I'm going to take both sides to the negative half power. And that will be, it's a general solution. If I want the particular solution, I'm going to plug in f of 1 equals 2. So 2 equals negative 1 plus c to the negative 1/2 power. Take both sides to the negative 2 power is equal to negative 1 plus c. C is equaling 5/4. All right, so my solution, y equals f of x, is y equals negative x squared plus 5/4 to the negative 1/2. Okay, I'll stop there. All right, be happy. All right, number 3. Oh, oops. Hold on, it's stuck. All right, we're going to consider the differential equation dy dx is x plus 1 over y. We're going to sketch the slope field for the given differential equation at the 12 points indicated. All right, I think this will be one. I'm going to just pause the recording of this so I can just put these on. I don't think you need me to show you the computations. All right, there you go. And so here you have it. I've got... Okay, anywhere where x was -1, the slope was 0. That was kind of nice because x plus 1 over y. And then I just filled in the rest of them. I think that you could probably do that yourself. While the slope field in part A is drawn at only 12 points, it is defined at every point in the xy plane except for along the x-axis, right? Describe all points in the plane, y not equal to 0, for which dy dx is equal to -1. So what I'm going to do is I'm just going to kind of chase this down algebraically and then make an interpretation. So I've got dy dx equals -1. But dy dx is x plus 1 over y.
They should have released it earlier, and they should have released it.
So maybe I could just multiply both sides by y. And maybe I'll multiply both sides by -1.
Obviously, but we'll still go to it.
And so all of the points where dy dx is equal to -1 sit all along the line y equals -x minus 1. And I feel like x plus 1 over... yes. Okay, so this is actually a solution to the differential equation. It's not a very interesting one, but it does work. Okay, find the particular solution with the initial condition f of 0 equals -2. All right. So what I need is to do separation of variables.
This is the main rule.
1/2 y squared is 1/2 x squared plus x plus c. Start working on this. All right, and then f of 0 is -2, so -2 is equal to the negative square root of 4. So 0 plus 0 plus 4. C is 4. This is negative. So my, particular solution y equals f of x is y equals negative square root x squared plus 2x plus 4. And that is not, it looks like it's factorable, but it's not. Even if it was, I would recommend just, letting it be like that. Right? All right, last one, number 4. Consider the differential equation dy dx is y minus 1 over x squared, where x is non-zero. Okay, we're going to start by finding the particular solution. We know that means separation of variables. I'm going to say 1 over y minus 1 dy is x to the negative 2 dx. Okay, take the antiderivative of both sides. Okay, that's equal to negative x to the negative 1. Okay, I'm realizing I really should have made this 1 minus y. I think I made this one up myself. Yeah, I did. I really kind of am wishing now that I would have made this 1 minus y for there to be a chain rule, you know, kind of consequence. Oh, that may have made me unable to ask the question in part B. But a negative x to the negative 1, then plus c. Okay, I'm going to get rid of the log. C e to the negative x to the negative 1. Y minus 1 equals plus or minus c e to the negative 1 over x. Y equals 1 plus or minus c e to the negative 1 over x. Okay, if f of 2 is equal to 0, then I've got 0 equals 1 minus c e to the negative 1/2. All right. Well, hold on. If this is e to the half and I need this to be equal to 1, I need c to be e to the 1/2. All right, so y now is equal to 1 plus e to the 1/2 e to the negative 1 over x. Okay, you could combine these to be like negative 1 over x plus a half, or 1/2 minus 1 over x is the exponent of e, or you could just not, right? That's going to be, this is definitely an explicit formula for y equals f of x, the particular solution with f of 2 equals 0. Now that I've got this, I want to find the limit as x approaches infinity of f of x. Okay, well, okay, the limit as x approaches infinity of 1 plus e to the 1/2 e to the negative 1 over x. Well, e to the basically 0, right, is going to become 1. So this is going to be 1 plus the square root of e. Because the limit of this fraction here is 0 as x goes to infinity. E to the 0 is 1. This doesn't care about what's happening to x, and neither does that. Okay, and then over here, okay, well, the limit as x approaches 2 of 2 minus x is equal to 0. The limit as x approaches 2 of f of x is... Why is that? Oh, hold on. Yeah, you may have caught this. I was over here saying 1 minus. I need this to be a minus right here, which means that's going to change my answer over here also. That's going to become a minus. You know, the nuts and bolts are not going to change, but this will be a minus for sure, yeah. Okay, and the limit as x approaches 2 of f of x, you can either look at f of 2 equals 0, or you can actually consider that this is going to be a continuous function, except for where x is equal to 0. So, you know, it's going to, you know, in terms of limits, it's going to have to agree with function value because of its continuity. And since these are both 0, I'm going to use L'Hopital's rule. Okay. When I'm doing L'Hopital's rule, I'm going to take the derivative of the top and the bottom separately. Okay. So we just need to find out what is the value of f prime of x at x equals 2. And f of 2 is equal to 0, I know. So I'm going to go all the way back up here. F of 2 is equal to 0, so I've got negative 1/4. So I've got negative 1 divided by negative 1/4, which I think is going to be 4. Okay, that's all I got for you.